Hello guys, and welcome back to the Production Pipeline series with me, Elder from Logis Lumiere. This is chapter 12, and we're going to be discussing volume scattering and atmosphere here in C4DtoA. So, adding that extra punch and realism to your scenes can come at a cost depending upon the technique you use, but here in Arnold, cost isn't really that great in render time if you're using the volume scattering or the fog shader here in Arnold. So you can access those via Arnold volume, atmosphere, and you've got fog and volume scattering. Now, I haven't quite cracked the code on fog. It works okay, but it doesn't quite give me the overall kind of sort of just foggy atmospheric look with rays and different things that I would really like in my scenes. The volume scattering works kind of similar to if you were to bring in a volume animated or something from, say, Houdini as a VDB. The volume scattering works kind of sort of in a similar way, and it gives you a fog pretty much across the whole entire scene. Which you can then use to create some really cool atmospheric effects. So this is the technique that you're going to use to do effects that you previously would have done in Cinema 4D using something like volumetric lights. This is going to allow you to get actual visible light into your scene, and it just adds just a little bit of extra punch to your scene overall. Alright, so if I go ahead and stop the IPR really quickly here, and then I go ahead and switch over to the Forest Walker project, and turn the IPR back on, we're going to see in the Forest Walker project that we looked at in the last chapter, of course, that we have volumetrics here. There are, of course, a few other elements in this scene as well. Some refraction in these little balls that are in the background that are allowing them to glow really, really nicely when a light is put near them. But yeah, this scene finally cached here, so now we've got it. So just really quickly, these balls have a pretty interesting material on them. If we go into the jewel material here, we've turned down the diffuse quite a bit, and I'm primarily using a ramp as the diffuse color. Now, this ramp has in its input plugged a state float. Now, in Arnold, the ramps don't really have any idea by default of any sort of direction that they should take, and if you just plug in a ramp into a diffuse, and by the by, a ramp is pretty much a gradient. That's kind of what it's called in some of the compositing circles in like After Effects or Nuke. If you're a Photoshop guy or a Illustrator guy or a traditional 2D guy, gradients and ramps are pretty much the same thing. But if you just plug the ramp into the diffuse by default, it has no real idea of how it should lay itself out on the object, really, and you're not going to get quite the result you would expect. And so the state float allows you to define a directionality in a number of different ways for that ramp. So state float is always needed to kind of sort of get the ramp going. There's probably a few other nodes in Arnold that require that as well. But that's plugged into the diffuse, and in our refraction, we've actually set the refraction weight up, and we've set the IOR to some sort of jewel-like material. I've also plugged in a Fresnel, uses IOR, which is going to control, in turn, our specular, which is a very shiny specular, allowing us to see some reflections in the object. And our IOR is basically controlling our reflectance at normal, giving us some really, really nice jewel look. Now, because it's a semi-transparent material, the lights are going to bounce inside of it based on the IOR, and we're getting these really nice cool for nails and glows and different things off of this object. The text was done using a couple of techniques. I plugged in a AL cell noise, which is one of the I'm not even going to try to pronounce his name, but it's one of the AL shaders. So if you type in AL here, you can go ahead and bring up all those AL shaders. And a previous tutorial pointed out where those could be located. So once you have those installed, of course, you can go ahead and use his noises to define different looks. That noise is being used as a displacement input, which is displacing the text in these really cool ways. And cell noise is kind of like a, if you think of, if you go ahead and look up on the internet like a close-up on plant cells and different things like that, you'll get kind of an idea of what that noise kind of does. And I just played around with a few of its frequency and a few of its other properties to kind of sort of get the look that I was going for. That noise is also plugged into the bump map, which is also giving me a little bit of bump as well. Some more detail. And then I'm using a AL flow noise in the diffuse to give myself some really interesting colors here. Using pink and a kind of sort of offset red is kind of sort of offsetting it from the red, or from the green, since those are kind of complementary colors. I thought that would kind of sort of bring the title out a little bit. Alrighty, so that's how the scene is constructed. The scene has a quad light, which is acting as a highlight to give this text in the front some really nice shininess going for it. In the back, I've got a orange-based quad light, which once again is to offset this very distinct green that I've got going on with the fractal. Alright, and because it's behind the text and because we're using volumetric scattering, it's allowing light to pass through the text, and it's giving the text this offset appearance, like rays are coming through it. It's not very pronounced or very strong, and that's primarily because the quad light is kind of big, and the quad light also doesn't really have a extremely high exposure that's causing it to just really jut out light. Under the volume scattering shader itself, we don't have very many properties here. I don't usually mess with the contribution attributes too much, but under the main settings you have just a couple of properties. So the density is going to be how dense the volume is. The more dense the volume, the greater the fog, and the greater the diffusion of light. And because of the realistic way that Arnold calculates things, you're going to get a lot more light just scattering all over the place. At a density of 1, of course, you can see that the fog is just oppressive. The color of the fog obviously controls the color. Making the fog more of a gray is going to pretty much kind of sort of get rid of your scattering altogether. Bringing it over to a red is going to colorize the fog, or a blue or purple, what have you. So brighter colors are going to give you more fog and colorize, whereas darker colors are going to start to tone down the fog a little bit. Alright, attenuation is kind of unique. What it does is it takes the color value here and it basically causes light of that particular value to not make it through the fog. So if you were to make this red, then that means red rays wouldn't make it through the fog, and so you would start to get a distinctly blue appearance to your scene. So if we go ahead and make the attenuation color red, and then we just bring up the attenuation even up just a tiny bit, we're going to see that now red rays aren't making it as far through the fog, and so we're starting to get a decidedly bluish green tint to our image. As we increase the attenuation, even more red rays can't make it through, and so our scene is getting decidedly more and more blue/green. Vice versa, if we were to make this blue, the opposite color is going to be more of a red and yellow and green. So that's going to cause blue rays to not make it through, and we're going to get more of a decidedly yellow scene. And so basically attenuation is going to extinguish the fog a lot sooner. Here, basically no light is able to travel through, and because it's completely white. And so as the attenuation goes up on a scene like this, we're starting to reduce our ability to see a lot of our light. So you probably don't want to use a pure white attenuation in most cases. You're probably going to want to go with more of a colored attenuation to try to allow you to at least be able to see the background. But that's the general idea behind attenuation. It works the same way with the actual volume collector, but I'm going to save a discussion on the volume collector shader, which actually allows you to color volumes for a little bit later, when I go a little bit more into Houdini and how to bring in fire and explosions from there. All right. Anyway, how do we actually get to be able to see this effect? And of course, what do different lights do in this effect? Well, in order to actually be able to even use volume scattering, you need to go to your render settings and go to Arnold renderer here. And in your environment, you need to make sure that volume scattering is added to your atmosphere. In turn, if you were to use a fog shader, you would also need to add it to atmosphere. The background tab here is actually for the sky. So you can actually literally create an actual sky shader, texture environment, physical sky or sky. And if you've looked at any M2A tutorials, Maya to Arnold tutorials, this is the technique that most Maya users use to get a sky into Arnold. So the Arnold sky actually does all of this behind the scenes for you. It creates a sky shader for you, connects it into the background behind the scenes, and it also creates a sky dome light and then uses that sky as the coloration for the sky dome light. So the sky dome light allows you to have a lot more control over the lighting aspect of the sky, whereas the sky shader itself allows you to control the coloration and exposure of the actual sky color, for lack of a better way to explain that. And so the Arnold sky combines both of those together, so you don't have to use the traditional Arnold technique to actually create a sky shader slash skylight combination. All right. So once your volume scattering is in there, you'll start to see it in your scene. You increase your scattering, and that will allow you to start to see some density. But different lights have different effects here. So if we were to utilize without any lights in the scene at all. So right now we have a Arnold sky, and it's lighting our scene. It's giving us some nice global illumination, some ambient occlusion and everything. But the Arnold sky is not seen by volume scattering. Vice versa, if you were to use a Arnold light and you were to change that light to a distant light, distant lights also are not seen by the volumetric scattering. So you have to use a real light, a light that's not parallel or not like all-encompassing, basically. So if we bring in an Arnold light, by default this is a point light, so it's got infinite direction in all directions. It's infinitely casting rays in all directions with like no fall off whatsoever. And with a light like this, of course, we're starting to get that that kind of sort of ray look. where we're getting some shine behind our actual objects. So that's really cool. That's kind of how you can get those rays that come through your text like that. Another really great light to use would be a spotlight, which is going to give you a radius and a sort of cone of light through. And that's going to give you like a really, really good ray look. We come into the spotlight and we increase the cone angle outwards. We can get more of a 1080 degree cone angle where it's covering more of the text area. So as we start to scale that out, we can start to get that kind of sort of look for our spotlight. And then we can increase the exposure, and that's going to give us brighter and brighter and brighter rays coming off of our text. And now we can get this kind of sort of holy type of sort of look going here, where the rays are just really shining through our text. All right, so that's a really great light to use. In turn, we revert this scene to saved. Yes. If we go back to our Arnold landscape scene, we could use our Arnold sky or our physical sky as the actual color of our image. And so in this scene right now, we're using a dawn sun sky scene. And this scene, this sky actually has a sun, if you can see it kind of sort of here, built into the image. So it's got a really, really, really hot light that's giving us some really nice sunlight. However, because the sunlight is built into this image, we can't turn it off. And so we can't actually create our own sun. And if you want to increase the realism of your scene and kind of sort of get fog or whatever, you're going to need to create a fake sun of some sort, and you're not going to be able to really use a distant light to do that. You're going to have to use something like a cone light. And so that leads back to our chapter 11, our HDR workflow tutorial. You can create a sky that has no sun in it in Photoshop using some sky pictures and some clouds, and just generally giving it, some really nice 32-bit values a little bit to kind of sort of give the sky some overall punchy colorization. And you could then bring that in here as a HDRI and use something like a cone light to go ahead and light the scene with a actual sun that you can control. And if you were to do that, and if we go ahead and go into Arnold here and create a volume scattering, we need to go to our render settings and of course add that volume scattering to the scene. And then we need to create a light that we can use to scatter. So we're going to call this our sun light. And go ahead and change this light into a spotlight. All right. So we now have this spotlight that we can use to scatter some volumetric rays in our scene here. And we might be able to place this like above the mountains, so we get some like really cool rays above the mountains going here. May want to turn off our auto procedural temporarily so that we can see what we're doing. And if we go ahead and increase the intensity of that light to say, increase the exposure to say maybe 10. Point that light more downward. Maybe raise that sun really far up. And then Let's see, probably also going to want to, of course, increase our cone angle to almost nearly 180 degrees. All right, and so now you can see that we're getting some really nice hard shadows as well, something that we weren't really getting with our global illumination settings, our global illumination solution from the Arnold sky really quite as easily. We're getting some nice shadows from the trees as well. So we're getting these really nice hard shadows, really starting to creep this scene out a little bit. Under the volume scattering, of course, we can start to increase the density, and that's going to give us some really interesting rays coming in here. And so, assuming we didn't have, of course, a sun in our actual sky, we could get a lot of control. Now, you can get around that issue of the sun by actually using a physical sky and just disabling the sun. And now you have a sky procedurally generated from Arnold that is just purely giving you some really nice color, but it's not giving you any really hot lights. There's no bright light source that's offsetting any of your scene, and so you can use a fake sun like we have here for our cone light to kind of sort of do really interesting things. Our cone light may be just a little bit strong or a little bit hot. I like to set things to like 10 at first to kind of sort of get an idea of what I'm doing, and then I can tone it down. So we're getting a lot of shafts of light here that are going to take a little bit of time to render, of course, but it's going to provide so much more atmosphere to our scene and give us a much nicer look. As we can see, we're getting this really nice fogged out effect here of our quad lights, and she's shrouded in mist now. The scene has a completely different feel to it, and a much nicer mood than it had previously. Now that we've got these shadows going and we've got these rays of light and different things, it's a really beautiful thing. We could settle that down. Maybe 6 or 5 might be where we want to go with our intensity of our cone light for this particular scene. And then we probably just want to play with our volume scattering a little bit, maybe bring that down to about 0.4 perhaps, so that the scattering here in this light is just not so strong. And yeah, that is the idea. So volume scattering gives you really great atmosphere. I encourage you to play around with the fog too. It's not my favorite thing to use, simply because it's a little bit tweaky, and it's also, you can tell it's kind of sort of a fake effect. You have to really kind of sort of put it, you have to know how your scene is really laid out to really put it in the right spot and kind of get it going. I feel like the volume scattering here gives me significantly more control. One thing I did want to mention before I go about the trees is in the new version of Arnold here, 1.0.1, I believe the version that slightly came out before that, there's an actual new Arnold core for all the Arnold plugins. And in the new Arnold core itself, they actually increased the optimized the speed of opacity. So if you're using opacity maps, you can disregard what I was talking about in SpeedTree as far as opacity maps being slow. In Arnold, they're incredibly fast now in Arnold. So you can use opacity map trees and reap the benefits of both lower memory usage as well as extremely fast rendering, the same as any other rendering engine that you would be used to. So, alrighty guys, that's it for this one. In the next one, it's going to be pretty exciting. I'm actually going to be going over AOVs, drivers, motion blur, and depth of field. So we're going to finally go ahead and get one of these scenes exported. We're actually going to go ahead and work on the Forest Walker scene because this scene has a lot of separate elements and different things, and this scene's going to be a little bit more exciting to composite than my current Testa scene right now. We haven't really set up anything that really needs to be necessarily composited. So this scene, we're going to go ahead and use our Arnold object masks to be able to separate the elements out, to be able to color correct them separately. We're going to be using, we're going to go ahead and animate this a little bit so we can get some motion blur going. I'll show you how to set up depth of field, and basically going to be going into some serious compositing in the next one. So see you guys there.